Okay guys, and welcome back to the Anvil. Today we're going to be talking through the 4S model of strength, how it forms the lens through which we screen all of the different movements that we perform within a strength training program, and ultimately how it governs the direction in which we apply your training. It basically serves as a systems way of thinking in which we can delineate different training practices and make sure that we optimize the training process. Let's dive straight in. So the first S stands for muscle size. Second S stands for structure, third is for stability, and is for strength. So before we dig any deeper within the 4S model and go through each component part, one thing I will say is we can find weakness within more than one area of the 4S model. So it's not to say that if there is a problem with muscle size that there won't be a problem with stability as well. It's purely about trying to identify where that weakness comes from. More common to see at least two of these have an issue because they tend to have a play off one another. As you'll see when we dig in a little bit deeper in a moment, structure and stability are very closely linked, and it's actually very, very common to see both of them taking place. Although, in terms of how we organise our thoughts, they are distinct characteristics or distinct categories of training modalities. Now, let's go through each of them in turn and talk about how the different training practices that you may have heard of in the past all fall into one of these categories. So, muscle size. Specifically referring to muscle cross-sectional area, we're talking about the hypertrophy of individual muscles, so talking about trying to increase their size. Now for certain people this may be a great avenue to go down, and for other people it might not necessarily be what we want to focus on. However, the size principle within individual muscles doesn't just refer to their overall volume, but also individual contractile characteristics, so talking about the muscle in isolation separate from other movements. So when we're talking about how to increase muscle size, if the individual either A, needs a greater cross-sectional area in order to exert more force and produce more weight, then they will also follow the same rules that an individual would have to follow if they were to correct a muscle imbalance. So let's talk about that first. So certain people, the cause of which does differ between individuals, but certain people will present with muscular imbalances. This can be brought about through previous injury, so for example if people have had an orthopedic or musculoskeletal surgery, for example, muscular imbalances are really common from that. It's also common to see that societal positions that that we find ourselves in also have an influence, so being sat for prolonged periods of time, driving, that type of thing, and it's really common to develop these muscular imbalances. Certain muscles that are common, if you look at the epidemiological studies that are common across everyone, core weakness, so the abdominal muscles are underdeveloped or atrophied. Muscles around the scapula or the inferior border of the scapula that maintain this kind of upright position, they found to be atrophied as well. And essentially what we're looking at doing is not only increasing muscle size to try and produce more force to lift more weight, but also increase muscle size in those areas to correct muscular imbalances. Now, when we talk about muscle size, we're looking at hypertrophy and all the characteristics that go into that, and everything you'll have ever learnt about building muscle. So what rep ranges do we work within? So we're going to cover it briefly today, but we do actually have the muscle mastery series in which we talk about the three main principles of muscle growth, so you could check those out in much more detail. But essentially we're looking at progressively increasing the time under tension and the total volume that a muscle experiences. Now, within this kind of lens in which we view individual weaknesses within different movements, we can often find that muscles can be so weak that subjecting them to any kind of intensity that exceeds a certain threshold actually makes that muscle switch off. Muscles do actually have intensity thresholds, and when you take it to the extreme and try and lift a weight that's far too heavy, we see these compensations occur. So for example, in the deadlift, if an individual has to hit the deadlift in the final position of the rep, that's often brought about by weakness, or rather a lack of size within the glutes, and a lack of activation of the posterior chain. In which case, we need to focus on, like I said, gradually increasing the volume. Now, volume can be calculated in a couple of different ways. Either A, tonnage, which is the sets times the reps times the load, okay, which isn't necessarily the most ideal way, and we'll talk about that in a moment, but the other way is to calculate the sets times the reps, so the actual volume, and the average intensity. Now, the reason that we tend to prefer the latter, for at least most people anyway, is it's very easy to try and make up the tonnage, again, like we said, sets times reps times load, make up the total tonnage by lifting weights that are significantly lighter than what we would need them to be. So I've often worked with people where we've started on tonnage because it's a metric that's a little bit easier to quantify, okay, because you're literally just calculating the weight that you're lifting, but eventually we'll progress onto the, like I said, the volume with the average intensity. And like I said, what we're looking at doing there is subjecting that to the 4 laws of training. So consistent, specific progression that's best suited to you as an individual. And this often comes in the form of isolation exercises, okay, particularly in the earlier stages in which we look to develop just that muscle itself. So let's take the quadriceps, for example. If you presented with a size issue in the reference to you've had a previous injury, okay, we would start with exercises that isolate the quadriceps rather than trying to dive in to increasing their overload within exercises like the squat. And this is primarily because the body, like we've said before, is a very efficient mechanism, and when it's placed under stress, it will take the path of least resistance. Now, we can adjust certain parameters of a movement to try and emphasize that specific muscle itself. So for example, research has shown that the quadriceps might be a little bit more active in the front squat versus the back squat. But as I've said, from a coordination standpoint, what we're looking for here within the muscle mastery kind of phase is to gain an appreciation at least for the mind-muscle connection as well. So again, just to summarize, within muscle size, when we're looking at increasing it, we tend to focus on all of the aspects of muscle hypertrophy in isolation and just focus on improving the contractile quality of the individual muscle before we integrate it into larger compound movements. And like I said, we tend to see, it's not a hard and fast rule, this is just a kind of guideline to follow, we tend to see that size issues manifest themselves within concentric movements, and you'll see a little bit more as we go on. So structure, the second S of the 4S model, this refers to both passive and active mobility. So can the body assume the range of motion that it needs to with complete passive movement? So for example, I've worked with people that are so muscle bound and lack the structure that they physically cannot get their arms in a vertical position. Even if I try and move their arm, the lats are too tight, you know, they've got, sometimes it's not uncommon to see people with calcification of the shoulder and that type of thing. But also, do you have the active mobility? So can you move that joint into that range of motion that it needs to be in? Again, when we're looking, as we've talked about with things like the squat, we want a mechanically sound position and we want the structure to line up with the function. If it doesn't, we know that we're going to be having to compensate with other muscles, in which case that will obviously form the direction of the training, as we've said before. So within structure, you're looking at assessing the range of motion and assessing the mobility position that you need to be in. We tend to see weakness in structure, okay, within isometric or eccentric movements. Again, if that individual can't get into that position, or even if they can't hold it in position themselves, there tends to be a structural issue there. Easiest way to test this is if you've got the sufficient structure of squat depth, if you can squat down, okay, to the squat depth that we want you to be at, which is ideally below parallel. If you're unsure about that, just watch the Secrets to a Strong Squat video. But ideally to below parallel, and you want to keep obviously triple alignment in which your ankles, knees and hips stay in line with one another. If we get you to hold that position for, let's say, 10, 15, 20 seconds and your knees start to shake like crazy, then we know that there might actually be a structural issue somewhere around the hip joint there that's causing that lack of activation of the muscle. With this, we would use any mobility improving training modality to obviously improve your structure as well. So for some people, work at the Postural Restoration Institute works, in which we focus on the breath to try and obviously relax certain connective tissues and muscle tissue around that area, but sometimes something as simple as static stretching works as well. So the next phase is stability. We've talked about stability before, probably at length and more so than strength, because it is so important. It's the ability to resist force, okay, and it ties in with the tenet of tension over position. So where do we see stability issues manifest themselves? Primarily within eccentric or isometric contractions, and I'll explain why. When we talk about the individual contractile quality of the muscle, again, remember that falls under the category of size. Now, if there was an issue with the actual contractile quality of the muscle during an eccentric contraction, you physically wouldn't be able to lift the weight. And that's because most skeletal muscles are up to, depending on the individual muscle, but up to 60% stronger when lowering things than they are when lifting them. So if it was down to the muscle size and it appeared during the eccentric phase of the contraction, we know that you wouldn't be able to lift the weight. So what it tends to be, although it appears within the eccentric contraction, it's not because of that eccentric contraction. It tends to be a stability issue brought about by a lack of bracing or intra-abdominal pressure, rooting, and, like I've said, a mechanical position throughout the phases of the movement. Again, eccentric contractions tease out structural positions and tease out the technique and the proprioceptive feedback and all that type of stuff. Doesn't necessarily mean that they are directly related to it. And although we link eccentric contractions to stability on quite a strong basis, it's because eccentric contractions give us that greater feedback. On top of that, we can also see stability issues appear within isometric positions as well, okay? And this is typically because within certain movements, whenever we do see stability being challenged during an isometric position, it's because that joint is in an end range position. So an example would be pressing a weight overhead. It's really common to see that people have stability issues in that full overhead position. You know, it's not uncommon to see shoulder injuries and everything take place in that end range position, and it's because the shoulder is stretched, that is towards end range. And if you don't have that structural position, okay, and we're getting it into that end range position with additional weight, okay, we're going to see some stability issues take place. And that's simply because, like I said, muscle coordination isn't directly translated across the entire range of motion. That's why we will progress range of motion as a factor of mechanical demand with certain people, because it is so much harder to maintain that tensional focus at end ranges. So the final phase is obviously strength. With strength, okay, it's simple. It's the ability to express that force, and it tends to be, if we've exhausted each of those three principles before and it's still an issue, we know that there is an issue with size, we know there isn't any mobility restrictions, and we know that they're okay with stability, then it's simply a case of loading that movement. When we're looking at loading, we're looking at playing around with dose prescription, okay, and gradually increasing, like we've talked about before, the frequency, the volume, and the intensity. We'll also introduce variations that challenge weak points, okay? So for example, if that individual is spot on with bracing and everything like that, they have a decent mobility and they can get into a structural position, but we find that they are weak whenever the load is placed in front of them, and they have a strongman event, I don't know, that requires them to hold the weight in front, then we will shift the variation of the squat to an anteriorly loaded variation. If you're an individual that is struggling to pick something up off the ground, okay, we know that your muscle size is there, we know that you've got the glutes, you've got the hamstrings and everything like that. We know that your core is strong enough from a stabilization standpoint, and we know that you can touch the ground and you can touch, you know, you've got no structural or range of motion issues there. We need to start to overload that movement to be able to increase your strength. So just to summarize with the 4S model of strength and how we use it as a lens through which we screen movement. Muscle size, we're referring to the individual contractile quality of the muscle, okay, so can it produce force within all three contractions, so eccentric, isometric, and concentric, although we only tend to see the issue with muscle size appear during the concentric phase. We tend to train it within isolation, so we address that individual muscle first, then integrate it into other movements, okay? And then finally, we're looking at muscle mastery, which is progressively increasing the time under tension and the volume that the muscle is within. Structure, assess the range of motion. Can you get into position passively? Then can you get into position actively as well? Stability, it tends to manifest itself within eccentric contractions, but that's not because of the eccentric capacity of the muscle. That's just purely where we tend to see that take place. And it tends to be down to things like awareness of the movement, the bracing capacity of that individual, and the structural positions that they are within. We also see it within isometric contractions, namely in end range positions. So if you've got a weight overhead, you know, at the bottom phase of the deadlift, where that would be considered end range, or the bottom phase of a squat. Finally, if all of these three areas have been taken care of and there is no glaring weakness, it's simply a case of providing overload to the movement, getting that individual to gradually increase the weight that they can lift, and that will kind of take care of the movement quality that we need. What is the main focus of the 4S model? Simple, it's to be able to allow law 1 to take place. Can you remember what the first law of training is? Consistency. We're looking for movement quality to be consistent, or as consistent as we can get it, in which case we need to make sure we understand where our weaknesses lie. Okay guys, so I hope you enjoyed the brief kind of discussion about the 4S model and how we view different movements. I've just got a couple of questions for you, hopefully to tease out a little bit of curiosity and to get you guys talking about what it is that you've learned today. So, question number 1. Can you remember what the 4 S's stand for? Nice and simple. The 4S model, what does each S stand for? Question number 2. When we're talking about the stability aspect of a movement, and if there are any stability issues, can you remember the 2 forms of muscle action that we tend to see stability issues take place? Okay guys, and question number 3, purely a curiosity question this, there's no right or wrong answer, just want to know your guys' thoughts. If you were to video an exercise technique that you were to perform, let's take the squat as a classic example, looking through the 4S model, do you feel like you'd be able to tease out where your issues are being brought about from? If you would be able to identify which of the S's we see the most weakness, okay, and whether or not you'd be able to address that based off what each S stands for.